Welcome to CNN Cleaning's Cleaning Chemical class, where we talk about the chemicals that make cleaning, well, clean. In these two beakers, we're pouring some hot tap water, 250 milliliters per beaker. Then I'm going to add some vegetable oil. As you can see, the oil doesn't mix at all with the water. Most of us are familiar with this and learned it early on in school. Oil and water don't mix. We can heat up the water even more, but are we still going to get no mixing of the two? That is why cleaning with water only, no matter the temperature, isn't ever as effective as it should be. In the left beaker, I'm going to add a scoop of pre-spray, and when we stir it in, you can immediately see that the oil and water defy their own rules and mix. This is what allows us as cleaners to then remove the oil. By emulsifying it into a solution of detergent and water, we are able to then rinse it away cleanly. While we allow this to settle a little, let's talk about some of the terms you should be familiar with when talking detergents. First is hydrophilic. This means water-loving. Interestingly enough, water is very hydrophilic. It forms very close bonds with itself. This is the force that provides surface tension, how we can fill a glass up past the rim without it spilling. It is also a reason why the water doesn't mix with oil, which is hydrophobic or water-fearing. This causes the oil to push away and separate from the water. All of the soils we remove fall under three broad categories. Dirt or dry soil. These are the contaminants that are best removed dry by a vacuum or CRB, but they can also be flushed out with water and vacuum. Detergents may help on some of this, but most are inert like sand and really just have to be mechanically washed out through flushing large amounts of water. Lipids or oils are the fatty substances that make up a lot of soils that we see in our everyday life, of which we are representing today by this vegetable oil. Proteins are another kind of soil that we see a lot of. We'll do some playing with them in future videos. Both lipids and proteins benefit from chemically treating before removal. Both of these are also formed, like all organic matter on Earth, by long chains or rings of carbon atoms. And the length and shape of these chains, as well as what other elements are joined up with them, are what gives them their characteristics. So let's zoom in and see what is going on here. Closer and closer. We are all familiar with what water looks like, that Mickey Mouse looking head with an oxygen and two hydrogens. Water is polar, meaning it contains a differential charge from one side to the other, which is what makes it attract other waters and group up. The oil we are using in this experiment is vegetable oil, which consists of a glycerin group that bonds to several carbon chains called fatty acids. And here is a detergent molecule. This example is a sulfate, which is what many of our pre-sprays contain. On one end, we have a sulfate group which is polar, or containing an ionic charge. On the other end, we have a carbon group that is nonpolar. The polar end is very hydrophilic, and the nonpolar end is hydrophobic. When we get to a certain level of detergent molecules in solution, they begin to form micelles. This level of concentration is called the CMC, critical micelle concentration. Micelles are where the real magic happens. As all the hydrophilic ends begin bonding with the water around them, the hydrophobic ends are all pushed together to form a sphere of detergent molecules, and this sphere is able to catch and hold the lipid molecules within it, trapping the soils where it can then be flushed away successfully. As you can see, the detergent has done a great job of breaking down and surrounding the vegetable oil, so it can be mixed into the water for extraction. And no matter how well I stir the oil, it just won't mix well enough without the help of the pre-spray. I hope you've enjoyed this installment of Carpet Cleaning Chemistry. I try to make these videos informative and technically correct, but it's hard to go into enough detail without getting overly complex. Let me know in the comments how we did, and make a few suggestions on what you'd like to learn about next. Thanks for watching. Make sure you like and subscribe if you enjoyed this video, and ring the bell so you get notified when a new video comes out.